I'm Tate Simpson.
Hi, I'm Elisa Godinez.
I'm Robert Villarreal.
And I'm Zachariah Rollins. And we are here to demonstrate the capabilities of the wind tunnel that we designed for the TEM UK STEP Maymester 2013 Wind Tunnel Research Project. Our smoke supply is the dry ice, and we're going to go ahead and administer this and turn on our fan. And as you can see, we have water supply for our smoke supply, and our smoke is flowing slowly and smoothly over our object, demonstrating the Venturi effect and fluid in motion. One of the main focuses of our wind tunnel was to demonstrate individual paths of wind flow, which we've accomplished through our straw normalizers. And you can see how the wind literally moves around the building. And we do have other models.
We'll test other models right now so you can see the effects of the visualization of flow. So I'll pull this one out, and we'll put this, which represents a stadium bleachers that you would find at any stadium. It's much easier to see the effect, to visualize the flow over the stadium.
Now our smoke supply is dry ice in water, so the dry ice does have a time frame on it. So we're going to go ahead and jump into our bridge model. And the purpose was simply to test architectural models and to really see how the wind would flow around, over, and through architectural models for an architectural design class. We think that we have accomplished this, and if we want, we can also move our smoke screen up to get a little higher level on our model and view it when it hits the top or the middle, and basically cover the span of our model in terms of wind interaction and the aerodynamics. And we are running to that point when we will have water that is too cold to produce much more smoke. But we still got enough to see a little bit. And the other part of our mission, our objective in this project, was to be able to test the wind velocities and test the change downstream of our architectural model. So we built a grid to break it into separate sections, and then we've processed all of the data to find an overall level of consistency to find out if we have an even distribution of wind through our wind tunnel design. Our data is available in the PowerPoint. It's actually a present. But yeah, we're not actually taking measurements at this moment. We're just kind of demonstrating the way we would. You can see that the tube comes in about 10 to 11 inches in. If you get a longer tube, you can move it all the way to the back side of your model. But for our purpose, we just needed to show that we can literally test inside of the test chamber. And all we need to do is get a longer tube. Or, as our goal was originally mentioned, to test the models for the class, they will have a full-scale city block. So there will be 3 or 4 buildings, and they can test the building in the back, they can test the building in the front. We just wanted to see how all of it would interact, and basically have a way of testing and visualizing the Venturi effect.
And as far as our wind tunnel design is concerned, it's simple. We have pretty much 3 sections into it. One being the fan, which is the wind source. 2, the second one right here, which we call the contraction tunnel or inlet tunnel, which the air flows through. And then over here at the beginning of the test chamber, we have the normalizer, or what you would call air straighteners. And in this situation, we use straws, a little over 5,000 straws here. What that does is that it takes the turbulent air from this cone It goes through the straws and it straightens it out, giving us the ability to see that, visualize the flow of the smoke in a straight line. If not, if we didn't have that, the smoke would be turbulent all throughout the test chamber and you wouldn't be able to get good results. And then the last part, of course, is just our test chamber. We've obviously made it clear on top and bottom so that all students will be able to see the effects of the wind tunnel. And then the last but not least is our grid in the back. You can make it any size you want. We happen to put in 9 test squares, or test grids. So 3 on top, 3 in the middle, 3 in the bottom. And of course, that's where we take our measurements from. And this is completes our wind tunnel design.
Finally, your smoke source is a very basic design, just 2 tubes to run out, and they run straight into the lead-in tunnel. And as we showed before, you just lift up on both tubes, and you can get different height levels in your test chamber. Well, thank you so much for joining us. This is what we accomplished in the TEMU-K STEP Maymester 2013 Wind Tunnel Research Project.